Welcome friends! In this mini course, you're going to make your first 2D game in the Unreal Engine using the Paper 2D plugin. First of all, let's take a look at the game we're going to create, and then we're going to create a new project. Here is the game. We have a basic player controller that can go up, down, left and right. We have enemies spawning from all directions. We also have a score that we're keeping track of, and we're displaying the score at the top of the game. If we touch an enemy, it's game over, the player disappears, and then the game is restart after a couple of seconds. As you can also see, the score is resetted as well. And you can also tell that there's a background music and also a sound effect when the player touches an enemy. So this is the game that we're going to build. It's a very simple game. It's a great game to learn the basics of 2D development in Unreal. And first of all, like I said, we're going to create a new project. So open up the Unreal Engine. This is version 5.4.3, I believe. But any version that is like 5.4, 5.5 should work. Let's go into the game section here and pick a blank project. Unfortunately, there isn't a default 2D development template here, so we're going to have to create a blank one. We're going to pick C++ here for the project defaults, because in this mini course I'm going to use C++. You can also do the development entirely in Blueprint, but we're going to learn how to do it in C++ as well. For the name, I'm going to say my first 2D game. Make sure to pick a good location for your project and then hit create. This is going to take some time, so let's just wait for it to complete. So the project has been created, and the first thing we're going to do is to get rid of this open world map we got. We absolutely do not need this for a 2D game. So let's go ahead and create a new level. And this is going to be an empty level with nothing inside of it. We're going to save this in a folder that we're going to create in the content folder. We're going to call this levels. And we're going to save the current level inside of the levels folder, and we're going to call it the main level. Just like that. Here it is. Now we're going to go into the project settings from the edit menu, and we're going to set this as the default map or the default level. And to do that, we need to set the editor startup map to the main level and also the game default map, so that when we start the engine, this map is loaded, and when we play the game, this map is also loaded first. Inside of the project settings, we're also going to change a couple of settings. The first one is going to be motion blur. We're going to turn this off because it looks very bad in 2D games. This is a 3D feature, and we also need to turn off auto exposure. So let's turn it off. Here we're going to set it to be manual. And we're also going to set the exposure bias here to be 0. This is also a feature of Unreal that doesn't look good in 2D games, because if you think of it, Unreal is an engine made for 3D games. And we're trying to make a 2D game, so we're going to have to turn off a bunch of features, and the motion blur and auto exposure are one of those features. Okay. Now we're going to go into the edit menu again and into plugins. And here I'm going to show you the Paper 2D plugin. So if you type Paper 2D, you will see that there's a plugin here called Paper 2D. And this is the plugin that lets us make 2D games in Unreal. It adds support for sprites, flipbooks, tile maps, all sorts of different features that you need to make a 2D game. Of course, you don't have to use it, but it really makes it easier. And you can see that this is enabled by default. For some reason, if this is disabled for you, make sure to enable it. We're also going to enable a plugin called Visual Studio Integration Tools. And this is just a good plugin to use when you're using Visual Studio, which we're going to use. So if you're using Visual Studio, go ahead and enable this as well. We're going to have to restart the editor, but I'll do that off camera. I'm not going to do it now. And next up, we're going to bring up Visual Studio. And here we're going to go into my first 2D game. Here we have the source folder with all of our source code inside of it that was generated for us. And in here we have a file called build.cs. This has a list for all the dependency modules we need for this project. And by default, we have a bunch of them here. Now we're going to add paper 2D here into this list because we're going to use paper 2D as a module, so it needs to be included in this list. Make sure to do that and save it. Next up, we're going to go back into Unreal and we're going to import some assets. Here in the content folder, let's create a folder called assets. And in here, we're going to import the assets that I prepared. So you're going to find this in the description of this video. So make sure to download this and then unzip it. These assets are provided by Kenny. So the website is kenny.nl, except for this sound effect, which I created in BFXR. And also this whitepixel.png, but the rest is from Kenny. So thank you, Kenny, for these assets. Let's go ahead and select all of them and drag them into Unreal. You're going to see that one of them have been imported as a normal map. You want to say revert to that one. For some reason, when you have a blue asset like this one, it thinks that it's a normal map. But like I said, just say revert. Let's save all of these. Let's create a folder called textures, and let's create another folder called audio. We're going to put this sound called flowing rocks and the hurt sound effect here. We're going to select both of them and we're going to put them in audio, just like that. And the rest we're going to place inside of textures. Let's go into textures. And now we're going to learn our first, information about the Paper 2D plugin. The main thing we want to create is sprites, which are 2D images that we can use in the game. And the way you create a sprite is you take a texture, you import it into the engine, and then you right click and you say sprite actions, create sprite. But before you do that, you should apply Paper 2D texture settings right here. So we're going to select all of these, right click, and we're going to say apply Paper 2D texture settings. The Paper 2D texture settings by default is made for pixel art, but in this case, this is not pixel art, so we're going to have to make a change here. While we have them selected, we're going to right click again, go into asset actions and click on edit selection in property matrix so that we can edit all of these textures at once. And then we're going to go into texture and we're going to set the filter to be trilinear. When you have pixel art, you usually want this to be nearest, which I think is the default value here. This is nearest, but since this isn't pixel art, we're going to set this to be trilinear. I'm also going to set the tiling method here for X and Y to be clamp as well. And this is going to make them look nicer, because if you don't do this, you get some weird artifacts at the edges of the textures. So we're going to make these changes and save, and that's going to do these changes for all of these textures that we have selected. Okay, now that we did those changes, these textures are ready to use. You can click on any of them, right click on any of them, go to sprite actions and click on create sprite. And that's going to create a sprite that you can basically place into the game. Now you can just left click hold and drag this into the game, and then you can, as you can see it in the game world. Awesome. Of course, this isn't how we're going to do this, so let's go ahead and delete that. We're going to create another folder here in the assets folder called sprites. And we're going to place all of the sprites into that folder. So let's do this for the rest of these as well. I'm going to select all of them, right click, create sprite, and I'm going to move all of them into the sprites folder. Awesome, so we are almost at the end of this video. The final thing I want to do is I want to place some assets into the game world. We have a texture or a sprite here called the white pixel, and this is basically a single pixel that is white, and we can do some cool stuff with this. I'm going to drag this into the game, and I'm going to rename this to be the background. We're going to place this at, first of all, 0, 0, 0, and then we're going to scale this up to be 2000 on the X and 2000 on the Z. Let's see where this is. And as you can see, that's going to scale up to look like that. And then we're going to place this at 1000 on the X and negative 1000 on the Z. And that is going to basically center this on the origin. I'm also gonna I'm gonna go into this menu here, and I'm going to add a player start here. And this is going to be at 0, 0, 0. And as you can see, that is 0, 0, 0, and the background is centered around 0, 0, 0. And since this background is white, we can basically give it any color we want by changing the sprite color here. And I'm going to make this a light blue like that. And since this is a single pixel that is white, we were also able to scale this up to any size we want, and it's not going to look weird because it's just a single pixel. So by using this, white pixel sprite, we were able to create, a single color background like this, which is a simple trick that you can use. We also want to, while we have the background selected, go down and set the collision preset here to be no collision, because by default, sprites have collisions in Unreal for some reason. So we want to turn that off. We're going to leave player start at the center here because that's where the player is going to start the game at 0, 0, 0. And we're also going to create a camera. So let's go into this menu again. Let's just search for camera. We're going to bring in a camera actor. And first of all, we're going to place it at 0, 0, 0. We're going to pull it back a little. And we're going to rotate it -90 degrees so that it's looking at the background just like that. And we're going to change the projection mode of this camera from perspective, which is 3D, to orthographic, which is a 2D projection mode. In this mode, we're not going to have any perspective or any depth. So that means we can put the camera exactly, near the background like that, or we can place it very far away, and there isn't going to be any difference because there is no depth in this projection. So that means we can simply leave it at like 500, which is a good length for us to be able to see the camera. And I'm also going to go into the settings here, down here, and set auto activate for player to be player 0 so that we actually use this camera. Now when we play the game, as you can see, we're using the camera, and there's a black circle here, and that's basically the default pawn that was spawned. We can control it by using W and S, as you can see, but this isn't important because we're not going to use that. We're going to create our own player controller, which is going to be the default pawn. But as you can see, the camera is currently working. And if you eject here by clicking on that button, you can actually see the default pawn here. But like I said, we're not going to use that. And finally, I want to talk about the axes in the game world that we're going to use. You can tell that we are in a 3D game world, but we're making a 2D game. So we have an extra dimension that we're not going to use. And that dimension in this case is going to be the y-axis. So you can see that if you look at these arrows here, the x-axis is red and it's going horizontally, and the z is blue and it's going up and down vertically, but y, as you can see, is not in the 2D world that we're creating here. So that is going to be the extra one that we don't really use. So for example, when we have the player in the game, so let's actually drag the sprite in there. Let's put it at 0, 0, 0. It's going to have a horizontal position, which is going to be the X position, and it's going to have a vertical position that's going to be the Z position, as you can see. And the Y is mostly not going to be used. We can use it if we wanted to order stuff so that we see something above the other, but that's basically all we would do with the Y dimension. It's really an extra one that we have in here because we are in a 3D engine. Okay, so that's going to be all for this lecture. We created a new project, we did some settings, configuration in the project settings, we created a new map, we placed down the camera, the background, and the player start, and of course we learned some stuff about the Paper 2D plugin, and mainly how to create sprite assets, as you can see here. Thank you for watching, and in the next part we're going to start working on the player character. Hello friends, in this lecture we're going to start creating the player. The first step is to create a new C++ class. So let's go into the tools menu up here, click on new class, and from here we're going to pick a parent class. Now the parent class we pick has to be possessible because we want to use this, we want to control this as the player. Here we have two options, a character or a pawn. Both of these are possessible, but the character has a bunch of extra stuff like the character movement component, which is Unreal's built-in movement system. Since in this game the movement we're going to create is going to be extremely simple, we don't need to use Unreal's system because it's going to be a little bit of an overkill. Because of that, I'm not going to use a character and I'm going to make the player a pawn. So let's pick that, click on next. For the name, I'm going to pick player character and click on create class. That is going to create two files for me, playerCharacter.h and playerCharacter.cpp. And Unreal is also going to compile these for me, so let's wait for that to finish. Okay, the compilation is done. Now we can go ahead and start writing some code. If you get this, you can just click on reload all, and that should be fine. I'm quickly gonna get rid of these comments. I don't like them. Just like that. Let's also do the same here in the C++ file. Just like that. If you get these red lines, that's fine. Those are just gonna go away by themselves. As you can see, this is a class that's inheriting from the pawn class. It's called a player character, and in here we simply have some declarations for these functions like begin play tick and set up player input component. We also have the constructor. So nothing much is going on. This is basically an empty class. In this lecture, we're not going to do much. We're simply going to create the components that the player is going to use, and those are going to be a capsule component and a sprite component. So let's go ahead and include the files, the header files. The capsule is going to be components, capsule component.h, and the sprite component is going to be paper sprite component.h. Down here we're going to create the variables for these. These are going to be uProperty, visible anywhere, blueprint, read write. The first one will be the capsule, so that's going to be a uCapsule component pointer. We'll just call this capsule comp, just like that. And then we're going to create a uPaper sprite component pointer, and we'll call this sprite comp. So you probably understand what a capsule component is. It's just a collision shape that we're going to use for collisions. And the sprite component is going to show or display the sprite that we're going to provide to it. So very straightforward. Let's save this, go into the CPP file, and in the constructor, we're going to create these components. To do that, we're going to use the create default subobject function. This will take in the class. For the capsule, it's going to be uCapsule component. And then this is going to take in the name here, which we're going to see in the editor. And for this, we can simply say capsule comp as well. This function is going to return a pointer to the capsule component it creates, and then we're going to save that pointer in the variable we created in the class. Just like that. I want to set the capsule component as the root component. So we're going to call set root component, and we're going to pass the capsule component, just like that. Next up, we're going to create the sprite component, which is going to be very similar. So we'll just change that to be sprite component here and here. And we're also going to change the class name to be a uPaper sprite component. But this time, we're not going to set it to be the root. We're going to attach this to the root. And to do that, we're going to say sprite component setup attachment. and we can say root component here. And by this line, the root component variable, which is a built-in variable, should be the capsule component because we're making this call up here. Awesome. So this inside of the constructor is going to create the two components the player needs. And in this lecture, we're not going to do anything else in here in the code, at least. So let's go ahead and exit out of Unreal. Let's also close down this live coding thing. And we're going to right click here, rebuild the project. And after that, we're going to create the blueprint for the player. So the compilation is done. Let's go ahead and create a new blueprint. In the content folder, we're going to right click, create a new folder, and call this blueprints. Inside of this folder, we're going to right click again, click on blueprint class, and from the list, we're going to do a search for player character. This one right here. The name is going to be blueprint underscore player character. Just like that. Let's open it up. Inside of the blueprint, from here, from the components, you can see the capsule component and the sprite component we created inside of the code. And you can also see that the capsule is the root, just like we set this up. First of all, we're going to set up the sprite component. So let's click on that. The source sprite here is going to be blue player sprite. Just like that, as you can see. And currently we're looking at this from a 3D point of view. And to get a 2D point of view of this, we can go into this list here. So if you click on perspective, you have these orthographic points of view. And the one I like to use is the right view. And from this, you can actually see what this is going to look like in the game. And we can also do the same thing from the level as well. Just go into perspective here, click on right. And when you first do that, it's going to be in the wireframe mode. So you simply have to click on wireframe and then go into lit. And you also want to usually go into show and turn off the grid. But currently it seems to be fine actually. But as you can see now, the grid outside of the background is gone. Okay. So back to the player. In the sprite, we're going to do one more thing, which is going to be setting the collision preset to be no collision, because we don't want the sprite itself to have collision. The collision will be done with the capsule component. And finally, we also want to make sure that the material here is set to be translucent unlit sprite material. In order to see this, you might have to click on this gear here and turn on show plugin content. So make sure that's turned on, and this material will be used so that we can sort the different sprites in the game. I'm going to explain this more in the future, don't worry, just make sure that it's using this one. Okay, so that's the sprite. Let's also set up the capsule. The capsule has a half height and a radius. The half height is going to be 40, and also the radius is going to be 40, and that's going to create a circle, as you can see. And if you look at this from the perspective, you will see that it turned into a sphere, which is perfect because the player is a circle. So that is exactly what we need. I'm also going to go down into the collision here and set the preset to be a pawn. Okay. So that's all we need to do here for the player character. I'm going to, as the next step, create a game mode so that we can set this player blueprint as the default pawn. So let's go ahead and get rid of this blue player sprite. Let's, inside of the blueprints folder, right click, create a new blueprint class, and this is going to be a game mode base. We'll call this blueprint underscore my game mode. Just like that. Open it up. And the only thing we need to do here is set the default pawn class to be blueprint player character. save, compile, and then we're going to go into the project settings, into maps and modes, and we're going to set the default game mode to be the Blueprint My Game mode so that we actually use it. Okay, now when we play the game, the player blueprint should be spawned at the player starts position, as you can see. We can click on it from the outliner, and you will also see that the location for this is 0, 0, 0, exactly the same position as the player start. Great, so we have the player in the game, but of course currently it's not doing anything. So the next steps are going to be setting up the input system so that we can interact with the game using the keyboard, and then implementing the movement code in the player class so that we can actually move the player. So those are going to be the next two steps. Before we end this lecture, I want to talk about two more things. The first one is going to be the translucent unlit sprite material. So like I told you, we're going to use that to sort the different sprites we have in the game. So if you click on the background, let's also switch this to use the translucent unlit sprite material. And once you pick this material, you can go down into the rendering section right here. And if you open up the advanced portion here, you will see that there is a translucency sort priority integer here. This determines which sprite is going to get drawn first. Currently, this is set to 0. Let's also take a look at this in the player. So click on the sprite, go down to rendering, click on advanced, and here this is also set to be 0. So for example, if I set this to be -10 and play the game, this time we're not going to see the player, because currently the player is drawn behind the background because of its sort priority being less than the background sort priority. But if I set this to be 10, that's going to be more than 0, and now we're going to see it. So this is the purpose of using this material. And this is one way of ordering our sprites for a 2D game. The other way, I think I mentioned it in the last video, is using the Y position of these sprites. So for example, the background is currently at Y position 0. I can place this at -10, and then I can play the game. And when I do that, you will see that if you eject using this button, or you can also press F8, you will see that, let's move very slowly. You can actually see that the player sprite is a little bit in front of the background. So this would be the other way of doing the same thing, but I'm mainly going to use the material. So I'm mainly going to put all of these at the same Y position. So let's put the background back at 0, just like that. And the second thing I want to speak about before we end it is the camera's property here called ortho width. So if you currently play the game area here is going to be a certain size. This is the size of the camera size, basically. We can control this using this ortho width variable. This is basically the width of the camera. So we can set the width, and then the height of the camera is going to be automatically calculated using the aspect ratio here. So for example, if I set the width to be 1280, then the height is going to be 1280 divided by the aspect ratio, which is 177777, and that's going to be 720, which is going to be an HD resolution. So that is how the width of the camera works, and I can set this to be something very small, and that's going to make the game area very small, and I can set this to be something large, like 1920, and that's going to make the game area large. So this is going to be important in the future because we're going to use this width of the camera to control how big the game is going to be. And with that, we're going to end the lecture. In this one, we created a new C++ class for the player, which is inheriting from the pawn parent class. Inside of here, we created the components that we need, which is a capsule component and a sprite component. And in the constructor, we're using the create default subobject function to create these components. And we also did the attachments. We're setting the capsule as the root, and then we're attaching the sprite to the root, which is the capsule. Then inside of Unreal, we created a blueprint using this class, and we configured the sprite and the capsule inside of the blueprint. After that, we created a game mode and set the default pawn as the blueprint we created, so that when we play the game, we actually get that blueprint as the player. And finally, we learned about the translucent unlit material and also the ortho width property of the camera. Thank you for watching. I'll see you in the next part. Hello friends, in this lecture, we're going to set the input system up so that we can control the player using the keyboard. First of all, I'm going to explain how this is going to work, and then we're going to switch over to Unreal and implement it. So first of all, we're going to create an input action that has a value of a vector 2. So it's going to have an x and y value, and these are going to be floats. We're going to use this vector 2 as the direction for the player. So for example, the x here is going to control the horizontal position. So if this is 1, the player is going to go right. If this is -1, it's going to go left. Y here is going to control the vertical movement. So if it is 1, we're going to go up, and if it is -1, we're going to go down. And these numbers here, these values will be controlled by the A and D keys, and also the W and S keys. A and D here is going to control the X property of the value, and W and S here is going to control the Y. So this is how the system is going to work. Now let's go ahead and start implementing this. So we need to do two things. First, we need to create the assets of the input system, and then we need to write the code that uses those assets to make it work. So first of all, let's start by creating the assets. In the content folder, I'm going to create a new folder called input. And in here, first of all, we're going to create an input mapping context. So right click, go into input, and click on input mapping context. We can call this input mapping context, let's see, _default. Just like that. We're going to create one more, which is going to be an input action. And we can call this input action _move, because this will be the action that makes the player move. We're going to open this input action up, and we're going to set the value type to be a vector 2D, because this value here is going to be the one I showed you in this explanation here. It's going to be this. We don't need to do anything else here. We're going to go into the mapping context. We're going to create a new action mapping for this. We're going to set it to be the input action move. And if you open this up, in here we can bind keyboard keys to this input action. We have a single binding here. We're going to click on this plus icon 3 more times so that we can bind 4 keys in total. And these keys are going to be D, A, W, and S. So simply click on this icon here and click on the key on the keyboard. So this will be D, this will be A, W, and S. These keys are going to control the value of the input action, and by default, they're going to set the X value here to be +1. That is the default behavior. For the D key, that's going to be fine, because the D key is going to make us go right. So it should change the X position or the X property to be positive. But A here should set it to be negative instead of positive. To make that work, we're going to create a modifier. So click on this plus here and select the negate modifier here from this list. Now the A key is going to make the X value here -1 instead of +1. So now we can use these keys to go left or right. The W and S here, they need to change the Y property instead of the X. So to make that work, for both of these, we're going to create a modifier and we're going to pick swizzle input axis values. This modifier is going to switch X and Y so that this key binding here changes Y instead of X. And you can open these up to see the way it's going to switch these input values. You can pick also different configurations here. You can also change it to Z, for example, with this one, but the default value is going to be fine to the way we want this to work. For W, this is going to be enough because W is going to set Y here to be +1. But for S, we're also going to use a negate modifier. So let's create one more and set it to be negate. Now S is going to set the Y to be -1. Awesome. So this is going to be the setup for the input mapping context. But of course, we can't use this yet because we don't have the code that takes use of this. That is going to be the next step. Let's go into the Visual Studio. We're going to do all of this in the player class, which is an acceptable place to do this. First of all, we're going to have to include a bunch of headers, which I'm simply going to copy and paste. And you can just pause the video and include all of these as well. And after that, we're going to create variables here in the class for the assets that we created, the input mapping context and the input action. These are going to be uProperty edit anywhere because we're going to set these from the editor. The first one is going to be a uInput mapping context pointer. Let's call it input mapping context. And then the second one is going to be the input action. So uInput action pointer move action. And if we had more input actions, we would also create variables for them. But in this case, we only have a single one. We're also going to create a function, actually two functions, that we're going to bind to this input action. So at the bottom here, let's create a function called move trigger. This is going to take in a constant f input action value reference called value. And we're going to copy and paste this and create a function called move completed. Just like that. And this is also going to take in the same argument. I'm going to explain how these work in more detail, so don't worry. For now, let's just copy and paste these into the C++ file and create the function bodies. We can do that at the bottom here, just like that. Let's also copy and paste the class name. Okay, now we're going to do two things inside of the setup player input component function. This function, just like begin play and tick, will be called by Unreal itself, so we don't need to call it ourselves. And this will be called at the very start when the player enters the game. So right at the same time with begin play, I believe. So this is a good place to set up the input system. In fact, it's basically the purpose of this function. And in here, we're going to do two things. First, we're going to add the mapping context. And then we're going to bind actions to functions. So those are the two things we need to do. To add the mapping context, we're going to have to get the subsystem, the enhanced input local player subsystem, to be specific. And getting that is a two-step process. First, we need to get the player controller. In here, we have a variable called controller already. And you can see that this is the controller that is possessing this actor. We can cast this to be a player controller. So let's say cast a player controller, just like that. And let's save that in a variable called player controller. And then we're going to check if the cast worked. So if player controller is not null, in that case, we're going to get the subsystem using the player controller. To get the subsystem, we're going to make a call to a function that's on the uLocalPlayer class called getSubsystem. This is going to take in the local player, which we can get from the player controller. So let's say get local player. And it's also going to take in the class of the subsystem that we're looking for, which is going to be uEnhancedInput local player subsystem. Kind of a long class name, but here it is. And this function is going to return it if it's able to, find it. So let's save this in a variable here, call it subsystem, just like that. And then we can make a check if subsystem is valid, subsystem, just like that. And if it is valid, we can finally make a call to subsystem, add mapping context, and then we can pass in the mapping context we have, and we called it input mapping context. And then we need to provide the priority, which is an integer. And this integer controls which input mapping context is given priority. So if you have multiple mapping contexts in the game, the one with the higher priority number is going to be used first. But in this case, since we only have a single one, it's not that important. We can just pass 0. Okay, so that's how to add the mapping context. You definitely don't need to memorize this. This is just, the process you need to follow. For me, I simply copy and paste this every time I make a new project. But in this case, since I'm teaching, I'm going line by line. Next up, we're going to bind the action, the move action, to these functions so that these functions are called when the move action is triggered. To do that, we need to get the enhanced input component. And in this function, we're given the input component here as an argument. We can take that and cast it to be the enhanced input component. So we're going to say cast uEnhanced input component. We're going to pass in the player input component. And then we're going to save it in a variable. Let's call it enhanced input component, EIC. And then we'll check if it worked. And if it did, we can make a call to the bind action function, which is going to let us create a connection between the input action, the asset, and a function inside of our code. The first argument is going to be that input action asset, which is going to be move action in this case. And then we're going to provide the trigger state, which is going to be eTrigger event triggered. I'm going to explain how this works in more detail a little bit later. After that, we're going to say the object, which is going to be this, and then the function address, which is going to be ampersand to get the address, and then the function is going to be a player character move trigger. Just like that. That's going to be the first binding, and then we're just simply going to copy and paste this, and this time bind the completed trigger state to move completed. Okay, so let me explain how this works. So the trigger states refer to how this move action is being used. So the state of the input action, basically. Triggered means this input action is currently being triggered. So for example, we have the W, A, S, and D keys bind to this input action. So if any one of those keys are currently being pressed, the trigger state is going to get fired over and over again as long as that condition is true. The completed trigger state here is going to be fired only once when we release the key. So for example, when we release, let's say the W key we were holding down, the completed state or the completed trigger state will be fired only once. We also have different states like cancelled, ongoing, and a bunch more extra stuff that I'm not going to get into, but this is the basic idea of how this works. And since we're creating these connections here, Now when the input action, the move action is triggered, this function here will be called. And when it's completed, this function here is going to get called. That means inside of these functions, we can, write the code to make the player move, or we can use the value of the input action, which I showed you here, and we can get that actually from this variable right here. But we're going to do that later. Okay, so that should be all we need to do in terms of the code to set this up. We're adding the mapping context and we're creating the connections between the input action and the function. So let's go ahead and exit out of Unreal. Rebuild the project. And then we're going to continue. So the compilation is done. Let's go ahead and open up the player blueprint so that we can set those variables we created. I'm going to scroll down until I find them. Here they are. So let's set these to the assets we created for them. Just like that. Now we can save, compile, and we can run the game. You will see that we're not able to do anything, but we actually have the mapping context in the game right now, and we can actually debug or see the values that we're setting to them. So I'm actually gonna open the game up in a new editor window by clicking on that, make it bigger, and while I'm playing, I'm going to press the tilde key twice, which is going to bring up this window, and here I'm going to enter a command called show debug space enhanced input. This is going to display a bunch of information about the input system. So first of all, you can see that we are using the input mapping context default, which is the one we created. So the code we wrote is working, which is great. And we can also see the input actions we have here and the value of the input action. So you can see that we have a single input action called input action move, and this has a vector 2D value, which we can see here, X and Y, exactly what I was talking about in the presentation. Now let's take a look at how these values change when we press the keys. You can also see which key I'm pressing down here. It will say true right next to it. I'm going to press the D key. And when I do that, you will see that the X is set to be 1. You can also see that the state changed to be triggered, and you can also see how long I've been triggering the input action for. I'm going to release it. It's going to go back to 0, 0 for the value, and you can also see that the state went back to be none. Now let's try the A key. And this time you can see that the X value is set to be -1. Let's try the W key. You can see that Y this time is set to be 1, and if we press the S key, the Y value is going to be -1. So we implemented the exact thing we were talking about at the start of this lecture, and now we can use these values, the X and the Y value, as the direction for the player. And that's going to be the topic of the next lecture. So thank you for watching this one. I'll see you in the next video. Hello friends, in this lecture, we're going to implement the player's movement code. First of all, let me quickly explain how this is going to work, and then we're going to switch over to Unreal to implement it. First of all, we are trying to move the player in one of 8 directions: up, down, left, right, or diagonally in these 4 directions. So a total of 8 directions. And in the tick function, we need to decide the next position the player needs to be in if the player is moving, if one of the keys we bound in the last lecture is being pressed. So for example, if we're pressing the D key, that means we need to go right, so we need to calculate how much we need to move the player, and we need to calculate that new location that the player needs to be at. And after we calculate that, we're simply going to call set actor location and move the player. That's the basic idea, and the calculation we need to make is going to require a number of variables that we need to create in the player class. The first one is going to be the movement direction. This is going to determine which way we go, and we saw in the last lecture that we can get this from the input system. So this will come from the input action move. We're going to multiply this with the movement speed, which is going to be another variable that we're going to create. Movement speed is going to control how fast the player is moving. So the movement direction here is not going to control how big this number is. It's simply going to be 1 or -1 in X or Y. So it's only going to control whether or not the resulting number is positive or negative, which is going to determine the direction. And like I said, this will control how fast the player is going. And finally, we're also going to use the delta time here so that this movement is frame rate independent. This is going to give us the distance to move. So that distance I just showed you that the player needs to move to be in the next location. So, like I said, we're going to take this distance to move and we're going to add this to the current location of the player, and that's going to give us the new location. But we should also consider the fact that the player shouldn't leave the limits of the map. So we're also going to check before we actually use this new location if it is outside of the limits of the map, and if it is, we're not going to make that movement. So that's basically how the movement is going to work. Now let's switch over to Unreal to implement this. So first of all, inside of the player character.h, we're going to create those variables that I was just talking about. So these are going to be, first of all, an edit anywhere float called the movement speed. Let's set this to be 100 by default. And then we can adjust this from the editor because we're making it edit anywhere. The next one is going to be the movement direction, and this is going to be visible anywhere because we don't want anyone to change this. This is going to be set from the input, so no one should be changing this. And this is going to be an f vector 2D movement direction. And after this, we're going to create two more f vector 2D variables, and these are going to be the horizontal limits and then the vertical limits. And these are going to make sure that the player doesn't leave the map or the game area, not the map. Okay, so these are the variables we need. Now let's go into the CPP file and start working with these. The player is going to move inside of the tick function, but before we do that stuff, we first need to get the movement direction from these functions that we bound to the move action. So the move action has that value we saw in the debug information, that vector 2 with the x and y value. We can get that inside of these functions from this value argument that Unreal is passing us. To do that, we're simply going to say value.get, and then we're going to type in the type of this value, which is an f vector 2D. And then we're going to set this directly equal to the movement direction. Just like that. So this is going to make it so that when we press the D key, the movement direction is going to be 1 and 0. When we press the W key, it's going to be 0 and 1. And let's say we press A and S at the same time, it's going to be -1, -1. We're basically setting movement direction equal to that value, and that's going to give us the correct direction we need to move in. And here, when the movement is complete, we're simply going to set this to f vector 2D 0, 0, so that the movement doesn't work anymore. Because in this multiplication here, if you multiply with 0, of course the result is also going to be 0, and the player isn't going to move anymore, which is what we want if the movement is over, if we're not pressing any one of the keys anymore. So now that we have the direction, we can start implementing the movement here in tick. Before we can move though, we first need to check if any one of the keys are currently being pressed or not. And to check that, we can simply check the length of the movement direction vector. So we can say movement direction dot length. If this is greater than 0, that means one of the keys are being pressed. So for example, if D is pressed, the length is obviously going to be 1. If W is pressed, it's going to be 1. So if any one of the keys are pressed, it's going to be 1. So like I said, we can use that logic here to move the player or check before moving the player, because if none of the keys are pressed, there's no point moving. But there's a important case here that we need to check, and that's the case where two keys are being pressed at the same time, because we're going to use the movement direction in the calculation. So because we're going to use it here. So let's say that only one of the keys are pressed. That would be like this, a vector like this, and that would have a length of 1. Or if we're pressing W, let's say, it would be like that. But if we're pressing both at the same time, then the resulting length of that vector is going to be like that, which is going to be more than 1. It's going to be like 1.4 or root 2. So this is going to, be applied in this calculation, and it's going to make us go faster diagonally compared to going up, down, left, or right. So because of that, we actually want to normalize the movement direction vector here if we're pressing two keys at the same time. Okay, so let's see how we're going to fix that. We're going to check if the length here is greater than 1. If that's the case, that means we're pressing down two keys at the same time, and we're simply going to call movement direction.normalize. And normalize is going to basically make the length of this vector equal to 1. So that's going to fix that problem. Next up, we're going to calculate the distance to move, this value right here. And you can see the formula for that right here. We're going to take the movement direction. So let's actually create a vector 2 here. Vector 2D, distance to move, and this will be movement direction multiplied by the movement speed multiplied by the delta time. And we're getting the delta time here as an argument to tick. And like I said, that's going to make it so that we're going to move at the same speed even at different frame rates. And now that we know how much distance we need to cover, we can actually calculate the new location of the player. And the new location is going to be an F vector instead of an F vector 2D, because as you know, the engine is working in 3D, even though we're making a 2D game. So when we're making changes to the location of the actors, we actually need to, start working in 3D. So this will be the new location. And the new location is simply going to be the current location, which we can get by calling getActorLocation, plus the distance to move. But of course, we can't just add distance to move like this, because distance to move is a vector 2, but this is a vector 3. So we're going to create a vector 3 here. And we're going to use distance to move.x and distance to move.y, like that. And you can see that I did not use the y position here because the game is taking place in x and z. So we're not using y. So that's an important thing to realize here. We're taking the distance to move.y, which is the vertical movement that we need to make, and we're applying that to the z position. Okay, so at this point, this would work. If we recompile the game, we're going to be able to go, we're going to be able to make the player move. But like I told you in the presentation, we need to make sure that the player doesn't leave the game area. So in order to implement that, we're going to do this addition here in 2 steps. We're going to make the player move, we're going to make the player move horizontally, and then we're going to check if the player has left the game area or not. If yes, we're going to take that movement back. And then we're going to do the same thing vertically. We're going to move the player vertically, check if they left the game area or not, and if they did, we're going to take that movement back. So that's basically how we're going to do this. And in order to make that work, we're going to create 2 functions. So here in the header, down here, we're going to create two functions that return booleans, and these will be is in map bounds horizontal. This is going to take in the x position, and then we're going to create is in map bounds vertical, and this will take in the z position. Let's create the function bodies for these down here. Paste in the class names as well. These are going to return a boolean, so let's create a result boolean, and we'll set this to be true by default, and at the end of the function we'll just return this. Let's do the same thing here, and in the middle we're going to check if the x position that we provided to this function is inside of the map limits, and we created the map limits variables here. So let's actually set these in begin play. And for them, currently I'm just going to say horizontal limits f vector 2d, and we'll make these, let's see, negative 640, positive 640 for x, for the horizontal limits, and for vertical, we'll say negative 360 and positive 360. In the future, we're going to calculate this based on the size of the camera, but just for now, we're going to use these hard-coded values. Okay. Now here we're going to check, is the x position here greater than horizontal limits.x, and is the x position less than horizontal limits.y. So if this returns true, that means, let's see, if this returns true, that means, let's say these are the horizontal limits, the player is somewhere in here, let's say here. If it returns false, the player is outside of these limits. And we're going to do the same check for vertical. We're going to check for these vertical limits and check if the z position is inside here. And here we were checking the x position. So let's copy and paste this. And this time we're simply going to check for the z position here, and we're going to check with the vertical limits. Okay, now we're going to turn this into a two-step process like I was saying. So we're going to first calculate the horizontal movement. So I'm going to take out this z movement here and say 0 instead of that. Then we're going to check. So we're going to check if we are in map bounds horizontally, and we'll give the new location dot x to this. And let's see. If this returns false, so if we're not in map bounds, we're going to take this movement back. So we'll say new location minus equals this. And next up, we're going to do the same thing vertically. So we're going to copy and paste this bit. We're going to get rid of this get actor location, and we're going to say plus equals, this time, the z movement, the vertical movement, that's going to be dot y. And this time we're going to check if is in map bounds vertical, and we're going to pass the z position of the new location. And if this returns false, we're going to take this movement back. So we'll say 0 there, and we're going to say distance to move dot y here. And after we do these, we can finally call set actor location. I didn't even realize we weren't calling this. So yeah, at the end, we should call this with the new location so that we actually move the player. So this should be all we need to move the player. We have the movement direction that we need. We're getting that from the input system. We're checking here if any of the keys are being pressed. And if both keys are being pressed, we're normalizing the movement direction so that we don't go faster diagonally. After that, we're calculating the distance to move, which is the movement direction multiplied by the speed multiplied by delta time. That's going to tell us how much we need to move in what direction. This is a vector too. After that, we're getting the new location. We're calculating that by taking the current location of the player, and firstly, we're adding the horizontal movement. After we do that, we check if the player is in map bounds. If not, we take that movement back here. And after that, we do the vertical movement. We add the vertical movement to the new location. We check again if we're inside of the vertical bounds. If not, we also take that movement back. And finally, we set the new location as the new location of the player. Hopefully that's all clear. Let's go ahead and exit out of Unreal. Rebuild the game. And then we're going to test this. Okay, now we can go ahead and actually test this. So let's play the game. And when I press W, A, S, and D, you can see that we can make the player move. He's a little bit slow, so we probably should increase the movement speed. And I also think he's looking a little funny, and I'm suspecting that is because of the anti-aliasing method. So we're gonna switch this over to be FXAA, and we're going to play the game again. And yeah, that fixes it. Okay. Let's go into the player blueprint. Let's go down to the variables we created, and here we're going to set the movement speed to be something like, I don't know, 400. Let's play the game again. Yeah, this feels much nicer. And you can see that now we can make the player move. And the map limits should also be working. As you can see, when I get to those map limits, which are invisible in this case, I can't go beyond them. And let's make sure they work in all dimensions. And we can also make sure that the limits are correct by changing the camera's width to be 1280, because that should give us a 1280 game area, which is going to have negative 640 the left limit and 640 the right limit, and 360 up and down, which is the hard-coded values we set in begin play right here. I did these based on that camera width, but in the future we're going to actually get the camera's width and calculate these limits based on that. But for now, we're just going to have these hard-coded values. So let's try this again. And you will see that in this map size, the player is exactly at the edge. I want the player to be able to go beyond the limit just a little bit, because I don't think it would look nice if we were stuck here, for example. So I want there to be a little bit of a margin, just like that. Great, so that's going to be all for this lecture. Now we have a top-down player that can move in all 8 directions, and he's obeying the game area size that we're setting. Thank you for watching. I'll see you in the next video. Hello friends, in this lecture, we're going to create the enemy. So first of all, let me just walk you through how the enemy is going to work, and then we're going to switch over to Unreal and start creating it. So first of all, the enemy, just like the player, is going to have a sprite component and a capsule component for the collisions. So that part is going to be the same. The enemy is going to also have some movement code, which is also going to be very similar to the player. We're going to calculate the new location, and we did this in the player by getting the current location and then adding the movement that we calculated. In this case, that's going to be the movement direction times the movement speed times delta time. So this part is also going to be very similar. In the player, of course, we had this in a 2-step process because we were checking for the map bounds. But in this case, since the enemy is not going to have any limits because we want the enemy to be able to go through the map, we're not going to do it in a 2-step process. We're also not going to check for any limits. So this part is going to be extremely similar and much more simple compared to the player, because this time also we don't need to do any input. The only input the enemy is going to have is going to be the movement direction, and that input will be given to the enemy when we create the enemy. So let's also talk about that part a little bit. So let's say that this here is the game area. Before we create an enemy, we're going to pick a random location on the edges of the game area. So let's say here. After we create the enemy, we're going to put the enemy at this location, and then we're going to give the enemy a random direction, which is going to be based on the direction of the player. We might even just use the player's direction actually. Yeah, maybe straight up just use the player's direction. So let's say that the player was here. We'll give the enemy that direction, and we'll send the enemy in a straight line. And if the enemy is able to touch the player, in that case the player is going to lose the game. So that's about it when it comes to the enemy. And also one more thing, the sprite of the enemy, which one we use, because we have 3 different enemy sprites, that's also going to be random, but that's going to be done from the enemy spawner, so we're not going to do it in this video. Okay, so this is the enemy. Let's go ahead and start implementing this. So first of all, we're going to create a new C++ class, and that class is going to inherit from the actor, because this time we don't need to possess it, so it can simply be an actor in the game, and the name is going to be enemy. But I already created this so that we can save some time, but you should go ahead and create this class. Let's go into Visual Studio and start implementing this class. It's going to have a ton of similarities with the player, so we can actually do some copy and pasting here to save time. First of all, I'm going to copy and paste these include statements at the top so that we can create the components, which I'm also going to copy and paste from here. Just like that. Let's also copy and paste some of the variables. So we're going to use the movement speed as well as the movement direction. Let's get those in here. And for the enemy, we're also going to create a timer. So for that, we're going to include the engine timer handle.h. And down here, we're going to create the timer, which is going to be an ftimer handle. We're going to call this the destroy timer. We're going to create a function for this destroy timer to call as well down here. And that's going to be void on destroy timer timeout. We can also create a float here that's going to control how long the destroy timer is going to go for. We can also do that. So up here we'll create the destroy timer duration float, which can be something like 5 seconds by default. And of course we can adjust this from the editor if we don't like it. Great, so that's all we need in the header file. Let's create the timers function in the CPP file. And then we're going to start implementing the rest of the code. First of all, we're going to create the components in the constructor, which is something we can copy and paste from the player. It's going to be exactly the same. Next up, let's set up the timer stuff. So at the start of the game, we're going to start the timer, or when we create the enemy rather, not the start of the game. So in begin play, when the enemy is created, we're going to set the timer, and when the timer times out, we're going to call destroy so that we get rid of this enemy, because if we end up having too many enemies and we don't destroy them, at some point that's going to cause some performance issues. In order to set the timer, we're going to call getWorldTimerManager dot set timer. This is going to take in the name of the timer, destroy timer, then it's going to take in this, and after that it's going to take in the address of the function that we want to call. So ampersand the name of the function. Then we're going to say 1 here, false to the loop, and then finally the delay is going to be destroy timer duration. So this delay here is not important because this timer is not going to loop. So this boolean controls that. if it were to loop, this time here would be used after the first time it times out. But since it's not going to loop, only this float here that we give is going to be used for the timer's timeout duration. Okay, so this should be working, and that means the only thing we need to do here is the movement code here in tick. So at the end we want to call set actor location with the new location. And the new location is going to be an F vector. And we should also calculate the distance to move, which is going to be an F vector 2D. Okay, so distance to move is going to be the movement direction times the movement speed times delta time. And then of course the new location is going to be the current location, which we can get by calling get actor location plus an F vector that we're going to create with distance to move. Just like that. So exactly the same thing we did for the player. Well, of course here we don't care about the map bounds. So we're doing it in one go. We're taking the current location and we're increasing the X and the Z positions by the calculation we made up here. And since the enemy is always going to move, it's never going to stop, we don't need to do any kind of checks here in tick. This should always get called, and the direction will be given to the enemy when the enemy spawner, which is something we're going to create, spawns the enemy. Okay, so this is all looking good. And before we actually compile this, I also want to implement the collision between the player and the enemy. And we're going to do that from the player. So the enemy is not going to handle any of that. It's all going to be done from the player. So in the player, we're going to use the capsule components, one of the delegates of the capsule components. And that delegate is called onComponentBeginOverlap. That delegate, or you can also think of it as an event, will be fired when there's an overlap between this capsule component and some other actor's component, collision component. We can bind a function to that, and then we can tell Unreal to let us know whenever there's an overlap. So to do that, we're going to create the function first, and that function needs to have a specific signature, which I'm simply going to copy and paste because it's a very long one. I don't want to waste time typing this out by hand. It looks like this. We're going to create this in the CPP file at the bottom, just like that. And then we're going to bind this function to that delegate I was talking about. And we're going to do that here in begin play. So let's get the capsule component. And we're going to take a look at onComponentBeginOverlap. This is an event or a delegate. We're going to call the addDynamic function. Not that one, this one. And this is going to take in, first of all, this and the address of the function that we want to bind, which is going to be overlap begin, just like that. So now whenever this event is fired, this function down here is going to get called. And inside of this function, we have access to the other actor that we collided with or overlapped with, which is this argument here. We also have a bunch of other information, as you can see, but the only one we care about here is the other actor. First of all, we need to check if this actor that we're overlapping with is the enemy or not. We can do that using a cast. So let's go ahead and include the enemy.h here so that we can use the class name. And then we're going to say enemy equals cast enemy other actor. And if this works, that means the other actor we collided with is indeed an enemy. And in that case, we want to basically make the player not alive anymore. This is the end of the road, end of the game. And we're going to do that by turning off the player's sprite and taking away the player's ability to move. And to control that movement and to basically represent if the player is alive or not, we're going to create a Boolean variable in the player. So inside of here, we're going to create a visible anywhere variable called, a Boolean called isAlive, which will be true by default. And then when the enemy touches the player, we're going to set this to be false. In fact, we'll check if we're alive first, because we don't want to try to kill the player more than once. If isAlive is set to true, we'll set it to be false. And then we're also going to say sprite component set visibility false to turn the sprite component off. We're going to do more stuff here in the future, like playing a sound effect, and there's a little bit more stuff, but for now, we're going to leave it at this. We also want to, stop the player from moving when this happens, so we're also going to check for isAlive in tick before we try to move the player. So we can create another if statement here and check for isAlive, and then we can put all of this stuff in that if statement, just like that. Okay, so this should be everything we need to do. Now we're going to go into Unreal, exit, we're going to rebuild the game, and then of course we're going to create a blueprint for the enemy, and then we're going to test this. So let's go ahead and create a new blueprint for the enemy. Enemy. I'm gonna call it, you guessed it, blueprint underscore enemy. Open this up. And we're going to configure the components, of course. The sprite component and the capsule. For the sprite, we're going to use one of these enemy sprites we have. So I'm going to just pick the green one. And I'm going to switch over to the right view here. We're going to set the the material to be the translucent material. We're going to set the collision preset to be no for the sprite, of course. And we're going to set the sort priority here to be, let's see, 10. What did we set it for the player? Let's see. Let's take a look at the players. The player should be above the enemies. We did 10 for the player. So let's say 20 for the player and 10 for the enemies. Okay. Next up, we're going to set the capsule, which is going to have a half height of 35 and a radius of 35 as well. That should be good for all of the sprites we have. And let's see. And we can leave the preset as this one. That is just fine. The sprite is going to be set in the end randomly from the enemy spawner. So it's going to use one of those 3 different ones we have. But just for now, we'll use this green one inside of the blueprint. Okay. Save and compile. And we can test this by putting one of these into the game. So let's drag one in. Let's make sure that the location, the Y position is 0. And then we can put it here. Save and play the game. It's not going to move because the direction is 0. And it should also delete itself after 5 seconds, which works as you can see. Awesome. Let's also try to touch it. When I do that, as you can see, the player just got killed. Okay, so finally, I want to give this a direction from the code and actually see if the movement is also working. I forgot to do this before we compiled. So we're going to go into the enemy, and in begin play, we'll just set movement direction dot, if I can type, dot x to be 1 and I don't know, y to be 0, so that it moves to the right. And this is just temporary, just to test. In the end, the direction will be given from the enemy spawner based on the position of the player. Okay, let's run live coding for this. let's play the game. And as you can see, the enemy is moving. It's moving very slowly, so we should probably increase the movement speed. And I think a movement speed of 300 should be enough for the enemy. It shouldn't be faster than the player. Or maybe it should. It depends on what you want to do with the game. Yeah, so this speed should be okay. And with that, we're going to end this lecture. Thank you very much for watching. If you liked it, maybe consider subscribing to the channel. In any case, take care. I'll see you in the next one. Hello friends, in this lecture, we're going to start working on the enemy spawner. The enemy spawner is going to be a big class, so it's going to take us a couple of episodes to finish. And in this first one, we're going to implement the main functionality of the enemy spawner, which is going to be spawning enemies. But we're also going to place some responsibilities like restarting the game when the player loses and keeping track of the score on the enemy spawner, so it's also going to be like a manager class. Okay, so let me explain how the enemy spawner is going to spawn enemies. First of all, the enemy spawner is going to get the size of the game area from the camera, so it's going to know how big the game area is in terms of width and height. Then it's going to pick a random position on the edges of the game area, so that could be here, here, here. It's going to use a random number to get this location. After it picks a random spawn position, it's going to spawn an enemy, place it at this location, it's going to spawn it at this location, it's going to give the enemy a random sprite, so that each enemy looks a little bit different and they don't look all the same. It's going to calculate the direction for the enemy, and we're going to do that in two ways. We're going to do it based on the center position, so that the enemy goes towards the center, and we can also do it on the position of the player, so that the enemy goes directly at the player. And there's going to be room for improvement here, so you might want to create a system that picks a completely random direction. So that might be something you want to do. Like I said, this is going to be the basic way the enemy spawner works, so let's go ahead and get started. So first of all, we're going to create a new C++ class for the enemy spawner, which is going to be an actor. Enemy spawner. I created this already so that we can save some time, but you should go ahead and create this. Now we're going to switch over to Visual Studio and we're going to lay down all the code that we need to successfully spawn enemies. We're going to have to include some headers up here. The first one is going to be the timer. We're going to have a bunch of timers in this class. And then we're going to include some of the ones we created, like the player and the enemy. Just like that. Now we're going to create the variables. So first of all, we're going to create the game area size, which is going to be visible anywhere. And we'll make this blueprint read-only. This is going to be an f vector 2D called game area size. The second variable is going to be an edit defaults only, so that we can only change this from the blueprint and not in the map. And this is going to be the enemy class that we're going to use when we spawn the actor. And this has to be a type of T subclass of a enemy. And we're going to call this enemy actor to spawn. This is just how Unreal wants us to create this. And without this, we can't spawn the actor. So this is important. Next up, we're going to create an array of sprites so that we can get a random one when we create an enemy. And these are going to be edit anywhere, and we'll make these blueprint read write. This will be a T array of view paper sprite pointers. And we're going to call this enemy sprites. Next up, we're going to create the spawn time float, which is going to control how fast we spawn enemies. It's going to control the time between the intervals. We'll set this to be like 3. You can always change it later on. And this means we're also going to have a timer, of course. So we're going to have a spawn timer. And we're also going to create a variable to hold the player. So we'll say a player character pointer player. So those are all the variables we're going to create. Now let's get to the functions. And first of all, we're going to create a set of functions that are going to control the spawning. So we'll have one called start spawning, one called stop spawning, and then one called spawn enemy. These are pretty much self-explanatory. This will start the spawning, this will stop the spawning, and they're going to do that using the timer, and spawn enemy is going to spawn a new enemy into the game. We're also going to create a function for the spawn timer to call, and that will be on spawn timer timeout. Okay, so that's all we're going to create here. Let's go ahead and create these functions. Okay, I think I will put this one above spawn enemy actually. And first of all, we're going to do a couple of things in the begin play function. I want to get the camera actor, and then I want to get the width of the camera and the height of the camera and use those as the size for the game. So that's going to be the first thing. And the second thing we want to do is we want to get the player, and we want to set the horizontal and vertical limits of the player using those sizes. So beforehand we were actually doing this by using these hard-coded values here. So now we're just going to comment these out. We're not going to use these anymore, and we're going to do this in the spawner. Okay, so to be able to do this, we're going to include some stuff, which are mainly going to be the camera actor.h, the camera component.h, and also we're going to include the gameplay statics. That's going to be Kismet gameplay statics.h. So first of all, let's do the camera. So we'll say get the game area size from the camera. In order to get the camera, we're going to make a call to gameplay statics get, let's see, did I mistype that? Gameplay statics, maybe like that. Yep. Get actor of class. This is going to search the whole world, and then it's going to return us this type of actor that we're going to provide if it finds one. And here we're going to pass, let's see, camera actor static class, a camera actor. It's like that. So it's going to try to find an actor with the class a camera actor, and then it's going to return it. But it's going to return, let's see, an actor pointer. So you're going to store that in an actor pointer called the camera search. And if the camera search is not null, that means it worked. We're going to cast this to be a camera actor, and then we're going to get the camera component from the actor, because that's what we ultimately need to get the width. Okay, so we'll say a camera actor pointer. Camera actor is cast. Let's cast it to be an a camera actor. The camera search. And then we can get the camera, let's see, is it U camera component. We'll say CU, and we'll get the camera component by calling get camera component, just like that. Okay, we did all of these so that we can call CU ortho width. This is what we want. So we're going to say game area size.x equals the ortho width, and then the y, the height, is going to be the ortho width divided by the aspect ratio, which is also something we can get from the camera component. Did I say CU? Why did I do that? It should be CC. I think I was thinking of this U here, but you know, it's too late now. It's going to be CU. Okay, so this is going to give us the correct game area size that we need to use in the game. And we can even print this out using a log if we are curious and we want to see this. So we'll say log temp display, and we'll create a text with 2 floats, which are going to be game area size.x and game area size.y. Okay, so that should be all good. And the second thing we're going to do here is give the player the limits. We'll basically do the same thing here first of all. So let's actually just copy and paste all of this stuff. And we're just going to change this to be player search. And we're also going to change the class here to be a player character. Okay, let's also change this to just player because we have this variable created already in the class. And we're going to cast it to be an A player character as well. And in here, all we want to do is we want to set the player horizontal limits .x and .y. And also the same thing for the vertical limits. And the x for the horizontal limit is going to be the game area size divided by 2 negative, and the y is going to be positive, the same thing, because the center of the game area is 0, 0, because that's how we set this up. So if the game area size here, the whole thing is 1280, that means this end here is negative 640, and this end here is positive 640. So those are the limits we're going to assign, and it's the same thing with the y here. If this is 720, up here is going to be 360, and down here is going to be negative. So this is positive, and down here is going to be negative 360. So that's what we're going to do here. So here, let's say game area size.x divided by 2, negative, and down here we'll just do the same thing but positive, and it's going to be same here for the vertical limits, but we're going to use the, let's see, the y component, and up here it's going to be negative, and down here it's going to be positive. Okay, hopefully we did the right thing here. We can test it later on using different camera sizes to make sure it works. But now that this stuff is complete, we can actually get to the main, functionality of this, which is going to be right here. So in order to start spawning, we're going to set the spawn timer. And each time the spawn timer times out, it's going to call this function, which is simply going to call spawn enemy. That's all it's going to do. So first of all, let's go to the enemy and get this line of code here so that we don't have to type it out again. And in here, we're going to start the spawn timer. And we're going to give it this function. And also we're going to use the spawn time here. Kind of a similar name. I should have just said spawn timer duration, but whatever. And this time, we're going to make it loop. So we're going to say true here. And because we're making it loop, we need to also use this float here. So I think I explained this before, but the timer, the first time it starts, it's going to use this time. And after it times out once, it's going to start using this one. So if you only provide one of these, you're going to get confused. So make sure you have both. And in stop spawning, we're going to make a call to clear timer, and that's going to just stop the timer. Okay, so let's actually call start spawning in begin play here. So will start spawning right away at the start of the game. Okay, so spawn enemy. This is going to be one big function. And the first part of the function is going to be calculate a random position, spawn position for the enemy. And then the second is going to be calculate the movement direction for the enemy. And the final part is going to be spawn the enemy and set it up. Okay, so in order to get a random spawn position, we're going to create a variable to hold it, of course, which is going to be an f vector 2D, or maybe we should just make it an f vector. We'll just make it a 2D. We'll call this the spawn position, and at the start we'll just set it to be 0, 0. And then we're going to pick a random position on the edges of the game area. And in order to do that, we're going to get a random float, and based on that float, we're going to do different things. So, okay. Let me just get that float, which is going to be, let's say, spawn chance, and this will be an fmath frand. This function is going to, let's see, we forgot the semicolon there. Okay, so this function is going to return a floating point number between 0 and 1. That can be 0.5, 0.6, 0.453, any number in between. If this number is less than 0.5, so okay, if that number is less than 0.5, we're going to pick one of these two sides to spawn the enemy. And if it's greater than 0.5, we're going to pick one of these sides. And the interesting part here is that if we pick one of these sides, the X position is going to be the same. And then we're going to pick a random Y position in this range. And if we pick these sides, the Y position is going to be the same. It's going to be either here or here. And then we're going to pick a random X position. And after we pick one of these two, for example, we're also going to pick one from each of these. So we're going to either pick this one or this one. Okay, so let's go back in here. In this case, we're going to say spawn position dot x is going to be game area size dot x divided by 2. And if the spawn chance is less than 0.25, we're going to multiply this by -1. So this is going to make it so that we're going to pick the right side, and if the spawn chance is less than 0.25, we're going to pick the left side. Because as you remember, this whole length is game area size.x, and here is 0, so this would be game area size divided by 2, and this would be game area size divided by 2 but negative. So that's what we're using here. We're picking the right edge, and if the chance is less than 0.25, which is also going to be another 50% chance here, we're going to pick the left edge. And we're going to do the same thing down here, but this time with the Y. So let's just copy and paste the Y here. And this time we're going to check for less than 0.75. Because if we're in this else statement here, the spawn chance is between 0.5 and 1. Here it's in between 0 and 0.5. Okay, and finally we're going to pick the Y, which in this case is going to be a random number in this range, which is going to be negative game area size dot y divided by 2 and positive of that same number. Hopefully this is clear. I feel like in my head that this is getting too complicated for you guys because of how fast I'm explaining it, but hopefully it's all clear. If it's not, just leave a comment and I'll try to explain it a bit more. So this is going to be an f random range, which is going to give us a floating point number from the range we provide. And in this case, it's just going to be game area size, negative game area size dot y divided by 2, and then the positive of that for the y, and down here we're going to do it for the x. Okay, at this point we have a random spawn position. Now we're going to calculate the direction for the enemy. And we're going to do this in two ways. The first is going to be sending the enemy to the center, and the second is going to be sending the enemy at the player. We're going to create an f vector 2D for the movement direction. And by default, we'll just set this to be 0. We're also going to create an f vector 2D for the center position, which is going to be 0 and 0 in our case, but if for you that's different, just enter it here. And the way we can get the direction vector is very simple. So let's say that you want to get the direction from the enemy to the player. Then you want to take the player's position vector and simply subtract the enemy's. So you take the second one and then you just subtract the first one. Very simple. So we're simply going to say movement direction equals the center position minus the spawn position, just like that. And the second way we can do this is by getting the location for the player, which is going to be an f vector this time. And we can say player get actor location. And then we can say movement direction equals the player position minus the spawn position. But of course, we're not going to be able to just subtract these. We have to create an f vector 2D. And make sure to use the z instead of the y. And finally, we need to normalize this movement direction, because when we normalize it, it's going to have a length of 1, so that we can use this in our multiplication in the movement, so that it doesn't change how fast we go, it simply gives us direction. And finally, we're going to spawn the enemy. That's going to be a call to the world spawn actor. The class is going to be a enemy, and this is going to take in the enemy actor to spawn. Then it's going to take in the position, which is the spawn position. But we actually need to turn spawn position into an f vector. So we'll say .x, 0 for the y, and .y. And finally, we're going to provide the rotation, which is going to be f rotator 0 rotator. This call is going to create the enemy and it's going to return it to us. So let's save that in a variable, and then we can check if it worked. And if it did work, we can do some setup here. And the main thing we need to do is we need to give the enemy its direction. So we'll say movement direction equals movement direction. That's very important. And the second thing we're going to do is going to be giving it a random sprite so that each enemy looks a little bit different. So to do that, we're going to get a random integer so that we can use that as the index for the variable, for the array we have here, the enemy sprites array. That's going to be random index, let's say. We're going to use another function from the math class, which is going to be rand_range, and the range is going to be from 0 to enemy sprites.num -1. So whatever is the size of the enemy sprites, in this case 3, we're going to subtract 1 from it, and that's going to be the range. So in this case, that would be 0, 1, 2. Those would be the numbers we get from this. And then we can use that with enemy sprites, random index, like that, to get a random enemy sprite each time. And we can simply say enemy sprite component set sprite, and then we can do that. Okay, so that's going to be all we need to do in this lecture, in the code at least. It was a lot. Hopefully you were able to keep up. But let's go ahead and exit out of Unreal. rebuild the project. And then we're going to create a blueprint for the enemy spawner, set it up, configure the blueprint, and then test it. So let's go ahead and create a blueprint for this. Enemy spawner. We're going to call it blueprint underscore enemy spawner, following the same naming convention. Let's open it up. We're gonna have to set the enemy actor to spawn and the enemy sprites. This one is going to be blueprint enemy. Make sure to pick the blueprint and not the regular enemy. Pay attention to that. And for the enemy sprites, we're going to create 3 elements here and pick the ones we have inside of our assets, just like that. We can also change the spawn time if we want to from here, which is good to know. Let's save and compile this and bring it into the game. We can also get rid of this enemy that we created. We don't need that anymore. And let's also put the enemy spawner at the origin of 0, 0, 0. Awesome. Okay, so let's take a look at the camera. Currently the ortho width is 1280. So the game area size should be 1280 by 720. I'm going to play the game. And first of all, I'm going to check the logs. As you can see, the spawning is working. And in the logs, we should have the game area. What did we say? I think we just printed it. Right here, as you can see. The game area is 1280 by 720. Okay, so that first calculation we made up here is working. This one right here, great. And let's now test if the limit setting is working or not. So I'm gonna play the game again and hopefully not die while I'm testing this. Okay, those seem to work. And this one too. Okay, they all work. I'm also gonna test it after changing the size. So maybe let's set it to be something larger, like 1920. And as you can see, it's also working now. And we did not have to set this by hand. This is now being done in the enemy spawner. Great. Awesome. So we're gonna set the size back to be 1280. And now I'm gonna focus on testing the spawning. And you can tell that it's working because we have enemies being spawned, and currently they are going towards the player and not the center because we're doing the player one after the center, so that was the one that was set. Okay, so that's clearly working. I also want to see if the enemies are being spawned roughly from the correct position, and to be able to test that, I'm going to let's see, let's click on the enemy spawner here and let's set the spawn time to be something very small, like 0.1. Let's play the game and let's detach. And we can roughly see that they are coming from the correct place. It's actually a little difficult to see. Maybe just 1 instead of 0.1. And with this you can see that it's probably correct. And we can change the game size to confirm that that's also working. Maybe make it very small. Okay, I'm going to say that that's working. So let's set the width back to 1280 and let's set the spawn time to be something like 2. I think that's gonna work fine. Okay, so that's going to be all for the enemy spawner. This was a long one, but there's still more to be done in the enemy spawner. So we're going to continue with that in the next lecture. Thank you for watching, and I'll see you in the next one. Hello friends, in this lecture, we're going to implement restarting the game when the player loses. So in order to create this, we need to let the enemy spawner know when the player dies. So that's going to be our first step. In the player, we're going to create a delegate, and then we're going to broadcast that delegate when the player dies, and then we're going to bind a function to that delegate in the enemy spawner so that we can restart the game. Okay, so let's start by creating that delegate in the player. Up here, we're going to declare a dynamic multicast delegate. We're going to call this f player died delegate, just like that. And then we're going to create a variable here in the player class of this type. And we're going to call this player died delegate. Now all we need to do is to broadcast this delegate when we want to, and that is going to be in the overlap begin function here when the player is dead. So we're going to say, we can get rid of this comment. We're going to say player died delegate dot broadcast. And the way this works is it's exactly the same as what we did up here with the capsule component. The capsule component has this delegate, and we're binding a function to that so that when that delegate is broadcasted, our function is also called. This time though, the only difference is we're also creating the delegate ourselves. So that's the only difference. So that means now we need to do this exact same thing from the enemy spawner. Okay, so let's go there. And we should also create a function so that we can bind to that delegate. And that function is going to be, first of all, it needs to be a U function. And the name is going to be onPlayerDied, a nice name that explains what the function does. Let's create this at the bottom. Just like that. And now we can go into begin play, where we get the player, and we can say player died delegate, and then we can say add dynamic, and this is going to take in this and then the address of the function, which is going to be enemy spawner on player died. Awesome. This is going to create that connection, and now when the player dies, our function is going to get called. So let's think of what we need to do when the player dies. We want to create, or we want to start a new game. So we want to first of all delete all the enemies that are currently in the game. Then we want to reset the player, and finally we want to start spawning again. And that also means that we should stop spawning when the player dies, because we don't need to anymore, the game is over. And then we need to do the stuff that I was just talking about. But we don't want to do them immediately. We want to wait a little so that the game feels nicer, because if we do these things immediately, it's not going to feel good. So because of that purpose, we're going to create a timer, and that timer is going to be the restart timer. Restart timer. We'll create a float for this to control how long it's going to take. This time I'll say restart timer duration. And 3 seconds should be fine for this. We're also going to create a function for this on restart timer timeout, just like that. We'll copy and paste this down here. And in here, we're going to have to set this timer. So let's get this code from here to make things easier. And we're going to set the restart timer. We're going to use this function. And this time, this one is not going to loop, so we can simply say false there and restart timer duration, just like that. And once this timer times out, we want to start a new game. We can do all that stuff that I was just talking about here, but we're going to have to do that twice because we also want to do that stuff here at the start of the game. So that means we should probably turn that into a separate function, and I'm going to call that function start new game. Let's put this down here. And we're going to call this function here instead of start spawning. We'll say start new game. And we're also going to call it down here on the timeout, start new game, just like that. Okay. In here, we're going to first of all destroy all the current enemies. And then we're going to reset the player. And then finally, we're going to start spawning enemies again. And we're also going to reset the score, but that's something we'll take care of later. But I'm just going to put the comment here anyways. Reset the score. Okay. So let's start by destroying all the current enemies. To do that, we're going to use a similar function to the one we used up here. This time it's going to be uGameplayStatics get all actors of class. This is going to take in the world. And then it's going to take in the class, which is going to be a enemy, static class. And then finally, it wants us to give it an array to put all the enemy actors it finds. So we're going to create one ourselves called enemy array, which is going to be a T array of actor pointers called enemy search array, actually, let's say. So this function is exactly like this one up here, only this time it's looking for multiple actors and it's going to place them into this array instead of returning them. Now we can check if this array has multiple or more than 0 elements in it. And if that's the case, we actually found some enemies. So let's say .num greater than 0. So of course, the first time we play the game up here, when we call start new game, this is going to be false because the first time we play, we don't have any enemies in the game yet. So the first time, this isn't going to be a problem, but the second time, third time, we're actually going to delete these enemies, which is what we want. In here, we can simply cast these to be enemies. So enemy, and let's say, what am I doing? We actually need to loop over this array first. Okay. Okay. So let's actually loop over this array first, and then we can do the stuff. The loop variable is going to be an actor pointer. Let's say enemy actor. Loop over the enemy search array, just like that. And then in here, we can cast the enemy actor to be an enemy, even though we don't actually have to do that, but just for good measure, maybe we want to do something else with the enemy. Just for good measure, like I said, we'll do this. And let's see. If that worked, and it should work, we can say enemy destroy. Awesome. So this bit of code is going to find all the enemy actors we have in the game, and it's going to destroy all of them. Then we're going to reset the player. So we do have access to the player here. Let's just do a check just for good measure. And then we can simply undo what we did in the player. So in the player at the bottom, we set is alive to false and we turned off the visibility. So we're basically going to undo these. Because now the player is alive again for a new round. We're also going to turn the sprite on, back on, and finally we're going to put the player back in the center position. So we'll say set actor location to 0, 0, 0. Okay, that should be enough to reset the player. We're not going to be able to do the score in this lecture, so let's do this part, which is going to be spawning enemies again, because down here we stopped spawning. So we can actually go ahead and just call start spawning and that would be enough. But again, just for good game feel, I want to do this a couple of seconds after the game starts. I don't want the game or I don't want the enemies to start spawning immediately. I want there to be a small delay, which I think is going to feel nicer. For this purpose, we're going to create another timer, which is going to be the game start timer. We can create a variable for this as well, so might as well do that as well. We did it for the rest of the timers, and this timer might feel sad. So game start timer, and I think for this I will say 2 seconds. Okay, and let's also create the function. On game start timer, timeout. We're going to put this down here. And this is just simply going to call start spawning. And here all we need to do is we need to set the timer. So let's say game start timer, and we'll say this function, it's not going to loop, and it's going to use the game start timer duration. Okay, so this should be all good. Let's do a final recap so that we can understand the flow of this. In the player, we now have a delegate. Don't worry if you get these red lines. These will usually go away after you compile the game once and then open back up. Now we have this delegate called the player died delegate, and we're broadcasting this delegate in overlap begin when the player dies. In the enemy spawner, we connected a function to this delegate called onPlayerDied, and that means this onPlayerDied function will get called when the player broadcasts that delegate. And when that happens, we're going to stop spawning because the game is over, and then we're going to set the restart timer for good game feel, for a little bit of a delay. And then in the timeout function, we're going to call start new game. And in the start new game function, first of all, we're going to destroy all the current enemies we have in the game. And then we're going to reset the player. We're going to place it back into the center, and we're going to start showing the sprite again. And then finally, we're going to set the game start timer, which is simply going to start spawning again, just for good game feel. Okay, with this, we should be able to play the game over and over again. Let's go into Unreal, exit out of it, rebuild the game, and then we can test this. Okay, now we can go ahead and test the game. Now there should be a 2-second delay when we start the game before we start spawning enemies, and as you can see, that's working. Let's also see if the restart is going to work. And as you can see, it does. After we lose, we wait 3 seconds and the game is reset. The player is back in the center and we can see it again. And the is alive boolean is also going to be true. Let's also maybe spawn more enemies to better see if the enemies are getting destroyed properly or not. So I'm going to put the spawn time to be 0.5. Play the game again. And we're going to have a bunch of enemies in the scene. And you can see that they all get destroyed. Awesome. We can also see that in the outliner as well, obviously. And if you don't like these times, if you don't like these values, you can always change them. That's why we made them edit anywhere. But yeah, with that, we're going to end this lecture. Now we can play our game forever, over and over again. If you liked it, thank you, I guess, and maybe leave a like. And I hope to see you in the next one. Take care. Hello friends, in this lecture we're going to implement the scoring system and the scoring user interface. So first of all, let me just explain how this is going to work. We're going to have a score integer in the enemy spawner, and we're going to increase this score every second by 1. So the score in this game is going to be like how much you survive or how long you survive. That's going to be our score. In order to do this, we're of course going to keep track of the score using that integer, score integer in the enemy spawner, but we're also going to create a user widget and the widget blueprint so that we can display this score on the screen for the player to be able to see. Okay, let's get started. First of all, we're going to create a new C++ class, and the type is going to be a user widget. We're going to use this class to create a widget blueprint, and the name is going to be my HUD for heads up display. I created this already, so let's go ahead and switch over to Visual Studio and start working on this. Inside of this class, we're not going to have a lot. We're simply going to have a text block, which is a user interface element, and then we're going to have a function called setScore that's going to change the text of this text component. First of all, we have to include the correct header for this, which is going to be components text block.h. And then we're going to create the variable for this, which is going to be a U property, edit anywhere. And this has to be a meta bind widget, because this C++ variable is going to be connected to a text block that we're going to create in the widget blueprint. And in order to create that connection, we have to use this meta tag here. And we also have to use the same name both in C++ for the variable and also the text block in the widget blueprint. This is going to be a type of uText block pointer, and we're just going to call this score text. And then we're also going to create the function called setScore, which is going to take in an integer called the new score. And this is going to use that integer to set the score text to its new value. Okay, let's go ahead and create this function. First of all, we need to create the string from this integer, and the string has to look like this: score, colon, and then whatever the new score is, let's say 99, just like that. In order to create this, we're going to use a printf call from the fstring class. This is going to be score, colon, and then a %d to place an integer in there, and the integer is going to be new score, of course. And then we're going to store this in a variable called string. And the next step is going to be setting the text of the score text block component. And that is going to be a call to score text set text. And this is going to take in an f text. So what we have here is an f string, and we need to turn that into an f text. We can do that by calling f text colon colon from string, and we're going to pass an str to this. And that is going to create an ftext class from the string that we provided. And this is all we need in here. Simply a function that's going to set the text of the score text using the new score integer that we provide. And we're going to make a call to this from the enemy spawner, and that is going to be the place we keep track of the score. Okay, so let's go into the enemy spawner and start to implement the rest of the stuff. First of all, we're going to include the my HUD header here, because it is going to be here that we actually create the widget, because that's also something we need to do. We need to create it. And in order to create it, we're going to have to create a bunch of variables. The first one is going to be very similar to the enemy actor to spawn here, because we need to know the class of the widget we want to create, and that is going to be a myHUD, and we're going to call this the HUD class, and we can leave it as edit defaults only. And we're also going to create a variable to store the pointer to the widget we create, and that is going to be, let's see, a visible anywhere myHUD pointer, and we can just call this HUD widget. Okay, those are the things we need to create the HUD. Now we're going to create the variables we need to keep track of the score. First of all, score is going to be an integer. We'll set it to be 0 by default. And we're also going to make this visible anywhere. We need to create a timer so that we can increase the score every second. That's going to be the score timer. This score timer is going to call a function, of course, so let's create that as well. And finally, we're also going to create a set score function here. Let me just create that here. Set score. This will take in the new score, just like the one we created in the HUD. But this time, this one is going to update the score integer, and it's also going to update the HUD, so it's going to make a call to set score from the HUD as well. Okay. We can go ahead and create these functions at the bottom here. Let's paste in the class name as well. And I guess we can start by implementing the set score, which should be very easy. We're simply going to set the score equal to the new score, and then we're going to make a call to HUD widget, set score with the score. Just like that. Very simple, like I said. And next up, let's do the timers function. So the timer is going to time out every second, and every second we're going to increase the score by 1. So here we simply need to call set score and say score plus 1. And that's going to do exactly what I just said. Okay, so now that these two are done, we can go into begin play and actually create the HUD widget at the start of the game. So we're going to do that down here. And first I'm going to check if the HUD class is valid. And if that's the case, we can make a call to create widget, which is going to take in the class name. And that is uMyHUD. And then it's going to take in the player controller, which we can get from uGameplay statics get player controller. This is going to take in the world and then the index of the player, which is going to be the first one, and that is 0. And we also need to provide the static class, which is going to be uMyHUD static class, just like that. Actually, that is not true. I think we're going to simply provide the HUD class here. And maybe both ways work, but this is why we have the HUD class. So let's just do it this way. And this is going to create the widget and return it. And we're going to, of course, save it in the variable we created for this purpose. And if this is successful, we can check for that and then make a call to set score, or we can just call set score to 0. And we also need to add this to the viewport so that we can actually see it in the game. Just like that. Awesome. So now this bit of code should create the HUD at the start of the game and add it to the viewport. And after that, we're going to set the score to 0 so that we update the HUD and also the score variable. The score variable should be 0 at the start, but like I said, just to update the HUD, we can do it this way. Now all we have to do is to set the score timer in start new game. So first we're going to say set score to 0, because at the start of a new game, we should set the score to be 0. And then we're going to set the timer. That's going to be the score timer. On score timer timeout, that's the function we need to call. And this is going to loop. And this is going to be a single second. I'm not going to create a variable for this, but if you want to, you can also change how often you increase the score. Okay, that should start the score timer at the start of the game. And we're also going to stop the score timer when the player loses. So here we're going to say get world timer manager dot clear timer score timer. And that's going to stop the score when the player loses, which only makes sense. Okay, so this should be everything we need to do. Let's do a quick recap here. So at the start of the game, we're going to create the HUD widget using the HUD class, and then we're going to store it in the variable. After that, we're going to add it to the viewport so that we actually see it in the game. Very important. And then we're going to make a call to set score with 0. And set score is going to set the score variable that we have here. And it's also going to make a call to the HUD widget's set score, which is going to set the text for the text component. That's all good. Then we're going to make a call to start new game. And in start new game, we're going to set the score to be 0 again. This is going to be kind of useless the first time, but the second and third and fourth time we play, this is going to be important. And after that, we're going to set the score timer to go and loop each second. And in the timeout function, we're going to increase the score by 1. So that's going to create the score mechanic in the game. And finally, when the player loses, we're going to stop it. So that's going to be the entire, lifetime of the score system. And of course, when we restart the game, when we call start new game again, we're going to reset the score and then start counting again. Okay, so that should be all, and that should be good to go. Now let's go ahead and exit out of Unreal, rebuild the game. And of course, we're going to create the widget blueprint, and then we're going to test this. Okay, let's go ahead and create the widget blueprint. We're going to go into the blueprints folder, right click, go down, scroll down, go into user interface, and at the bottom, there's the widget blueprint option. For the class, of course, we're going to pick my HUD right here. And I'm going to call this widget blueprint my HUD. Let's open it up. Now we're going to have to do some UI design, but we only have a single text component, so it's not going to take a lot of time. As you can see, this does not compile at the moment because the score text doesn't exist. And this has to exist because we made it, that meta bind widget thing. So now it wants us to create a score text here. First, we're going to put a canvas in here. So let's just drag that into the hierarchy, and then we're going to look for the text component and drag one of that into the hierarchy, and we're going to name this the score text, exactly the same name as that variable. Very important. Enter, and now you will see that it's going to compile. Great. So I'm going to anchor this to the center top. I'm going to, reset the position. Let's change the text to be score : 9999. And then we're going to increase the size. So let's go into the font, increase the size to be something like 110. Just like that. I'm going to make the alignment in the center. And then I'm going to put the alignment here to be 0.5 so that it is centered like that. And then I'm going to drag it down just a little bit. So maybe like 10. Okay, so that should be good to go. If you want to, you can spend more time here. And of course, later down the line, you can have more stuff in the HUD. But for now, we're simply going to have the HUD. Let's compile this. Now we have to go into the enemy spawner because we have to set that HUD class variable to this widget blueprint. Okay, let's save, compile, play the game. And as you can see, now we have a score HUD in the game that's counting up. And if I lose, it's going to stop, as you can see. And when the game restarts, it's going to back to 0. And then it's going to start counting again. And now we can actually measure how successful we are in the game. Great. So that's going to be all for this lecture. Now we have a scoring system. And of course, it's not perfect, but you can take this and you can improve upon it and implement your own ideas to make a more unique system that is unique to you, I guess. So thank you for watching, and I'll see you in the next one. Welcome friends to the final episode of the Unreal 2D mini course. In this one, we're going to implement the sound effect for the player's death and also the background music. The sound effect is going to be done in C++, but the background music will be done in Blueprint. So first of all, let's go ahead and implement the sound effect for the player. We're going to go into the player.h. First, we need to include the soundbase.h, and then we're going to create a variable for this so that we can give the sound effect asset in the Unreal's editor. Okay, so where should I put this? Maybe up here. We'll make this edit anywhere, but we'll make it blueprint read only. Shouldn't be touching this in the blueprint. And this is going to be a uSoundBase pointer. I'm just going to call this die_sound. And like I said, we're going to set that in the editor, and we're going to call this here in the overlap begin function when the player loses the game. And in order to play a sound effect, we're going to make a call to the uGameplay statics. Let's see, do we have that include in here? We don't. Do we have it here? We don't. Okay, I think we had it somewhere in here. Let's just copy and paste it. Alright, I think it was here. This is probably taking more time than me just typing it, but oh well. And down here we can say uGameplay statics play sound 2D. And what does this function want? It doesn't want to tell us, apparently. It wants the world and the sound, which is going to be die_sound. Just like that. That's going to be enough to play this sound effect. Okay, let's go ahead and exit out of Unreal. Rebuild the project. And then we're going to implement the background music. So let's go ahead and set that sound effect from the player, and then I'm going to show you how to do the background music. So let's open up the blueprint. Open it up. I hate this stupid stuff. Just go away. Just let me open the full thing. And scroll down to our stuff. Where is it? Oh my god. Let's say die_sound. Okay, here it is. We have the hurt sound, as you remember. We're going to use that. Play the game. Get killed by a shape. And there it is. Let's do it again. Sometimes in Unreal, for some reason, the sound effects, play a little late the first time you play them. There's probably a fix for them. Fix for that problem somewhere in the internet, if you want to look into that. But there it is, the hurt sound effect. Now we're going to do the background music, and honestly we can just simply call spawn sound 2D and play the sound, play the music, and that would be fine. But I want to show you a way that's going to work even if you have multiple levels that you're changing. So let's take a look at the level. We have the main level. Let's say that you have multiple levels and you're changing them while the player is playing. I'm going to show you a way that doesn't disrupt the music even if you do stuff like reloading the level. In order to do that, we need to find an object in the game that doesn't have a lifetime that's directly tied to the level. So it needs to have a longer lifetime than the level or the map. You might think that the game mode is like that, but no. The game mode actually gets reset after you change levels. The one that we need to use is called the game instance. Okay. Let's go ahead and create a new blueprint class. Let's type in game instance. Let's see. Game instance, this one. And as you can see, the description is high-level manager object for an instance of the running game, spawned at game creation. This is the important part. It's created at the start of the game and not destroyed until the game instance is shut down. So it's going to stick around until you basically close down the game. Let's just call it blueprint my game instance. And then we're going to have to set this as the default game instance in the project settings, just like the game mode. It's a very similar thing that we're creating. It's down here, game instance class. Now it's going to be blueprint my game instance. Awesome. Let's open it up. We're also going to use the game mode for this. And you're going to see in just a second how this is going to apply to the game mode. So in the game instance, we want to create a custom event called, let's see, play background music. A custom event is just like a function that we can call. And this is going to, first of all, check for a Boolean that we're going to create. And this is going to be, is music playing? It's going to be false by default. And we're going to check for this. So let's create a branch. And if is music playing is false, we're going to play the music, and we're also going to set is music playing to be true. And if is music playing is true, then that means the background music is playing already, so we don't need to do anything. And the function that we need to use to play the music is called spawn sound 2D. This is going to take in the asset, which is going to be, what was it called? Flowing Rocks is the music. This is also from kenny.nl. Thank you, Kenny. And here we can change a bunch of stuff like the volume. The volume is usually a little too high, so I'm just going to put this down to 0.2. You can play with the pitch. And here we're going to check persist across level transition, very important. And we're also going to uncheck auto destroy. Okay, so the final thing here is going to be saving the return value here. So the spawn sound 2D is going to spawn a sound and it's going to play it. And it's also going to return the audio component here as a reference. We need to promote this to a variable and save it here. So I'm just going to call this BG audio component. And if you don't do this, it's actually not going to work. If you don't do this and change levels in the game, the music is going to stop. So this is also something important. Hey guys, it's Khan from the future. We actually forgot to make the background music loop. So we need to go into assets, audio, double click on the music, and then turn on looping. And now the background music is going to keep playing after it finishes. And that is all we need to do here. And the reason we're going to use the game mode is we need to make a call to this event from somewhere. And in the game instance, we actually have an event here called init. So if you actually click on this override here, you can see that there's an init event, but this actually doesn't work. If you try to call the play BG music from here, it's not gonna work. As you can see, what we need to do is we need to call this function from the game mode. So let's go into the game mode. And here in the begin play function, which is called at the start, we're going to, first of all, get the game instance. And then we're going to cast the game instance to be the type we created, which is blueprint my game instance. And after we do that, we can call play background music, just like that. So the problem here is, like I told you, the game mode gets created at the start of the level. So it's going to keep getting created after you change levels. So this begin play is going to be called more than once. And that is exactly why we created this is playing Boolean here. because the first time we make a call to this function, isPlaying is going to get set to be true, and then the next time we call it, we're not going to try to play the sound again. So that's why we created that boolean. Okay, so now this should be working. Let's play the game. And as you can see, the background music is playing, and the hurt sound is still playing as well. Perfect. Now, I did teach you all this stuff for you to, keep the sound even if you change levels, but we're actually not changing levels, so I'm not going to be able to show you that part, but you're just going to have to trust me in this, that it also works if you change levels. Okay, so with that, we are at the end of the mini course. Now you understand a lot of things that you need to know in order to create a 2D game in Unreal using the Paper 2D plugin. Of course, there's more to learn, but this is a very good step for you, and you can take it from here and hopefully crush it. So thank you very much for watching it till the end. If you liked it, please subscribe to the channel, leave a like, I don't know, send me some flowers, and I'll see you in the next mini course. Take care.